Okay, so we basically are going to move out of the chapter of statistics into probability. Okay, and if you don't quite remember what probability is, it's basically, I always like explaining it because it tends to be a little more entertaining, as basically what are your chances to win a certain game that you'd be playing? What are your chances of winning? Okay, so you'll hear me talk about that a lot, but you'll hear me say a lot of other math vocabulary you'll have to be familiar with. Okay, so today what we're going to do is we're going to start very simple, and then it will increasingly get a little more challenging as we go. So we're going to start with probability of simple events. That's what the lesson's called. All right, so let's start off very basic, and we'll start off with the word outcome. Everyone? Outcome. So in your vocab, this is a possible result of a probability experiment. A possible result of a probability experiment is the outcome. Okay, now, just where you know, right, that's a possible, like what happens, what could happen when you're playing a game. That's kind of what that means, okay? So in your little box there, 4, this is just an example, 4 is an outcome when a number cube is rolled. You guys know, you'll see when it's talking about number cube, it's talking about dice or one die. So that's what they mean by number cube. Okay? So you roll it, 4 is one of the outcomes. Right? It's on one of the sides. Now, I want to talk about what we're actually talking about and that's a simple event. So simple event, everyone? Simple event. So here's what they mean by a simple event. This is where you have one outcome or a collection of outcomes. And we'll see some examples of this in just a bit. So one outcome or a collection of outcomes. So a simple event would be something like you're going to play a game, you're going to be trying to spin a 6 on a spinner. All right? So you have one of those little old-fashioned spinners, you're spinning it, there's one section's a 6. That's what it's talking about. That's one outcome during the game, and the game, of course, is that simple event. Okay, I kind of defined this next word earlier. But the next word is probability, everyone. Probability. And so your book says this is the ratio of the number of ways a certain event can occur to the number of possible outcomes. The ratio of the number of ways a certain event can occur to the number of possible outcomes. That's how we're going to be writing it. Now, go ahead and write that down. Okay, don't write down those outside parentheses because, of course, that's just like all these have parentheses. But write down the P and then 1 inside parentheses equals 1/6. Okay, when you see something like that, what that means is the probability of rolling a 1 is 1/6. You have a 1 in 6 chance, basically, to roll a 1. We'll get more into detail in just a bit on that. Next word is sample space. Everyone? Sample space. All right, so here's what a sample space is. The book says, this is the set of all possible outcomes. All right? The set of all possible outcomes. Any kind of outcome that's possible of when you're playing that game, that's what's called the sample space. So for example, you're rolling a number cube, right? So there's your sample space. 1, 2, 3, 4, 5, 6. It's basically like, it's a set. It's a listing of all of the different things that can happen. You can roll any of those. A sample space, by the way, is not, you could say how many are in the sample space, but that's not what the sample space is. The sample space is the actual things that can pop up when you're playing the game. Okay? All the different outcomes, not how many outcomes there are. And then we have something called a complement. Everyone? Complement. So here's what a complement is. This is one of 2 parts of a probability making a whole. one of two parts of a probability making a whole. Now, by itself, I think that definition is horrible, so we'll talk about this. So here's an example of a complement. Rolling a 1, and its complement is rolling something that is not a 1. So basically, both of them put together. So rolling a 1, of course, is rolling a 1. Rolling something that's not a 1 means rolling a 2, a 3, a 4, a 5, or a 6. So if you take a look, why it says making a whole is, of course, all of it. So like if you were to add them together, you'd have a 100% chance of winning, right? Oh, you win if you roll a 1. Guess what? You win if you roll something that's not a 1. Well, that's everything, right? That's 100%. But that's the whole point. Complements, when you put them together, means the whole thing. It's pretty much the whole sample space. Okay. Now, some of these might make a little more sense as we get going on our examples. Okay. So, kind of keep these in mind. Make sure if you're still stuck on some of these words. Okay. And they'll pop up in your questions. They'll pop up in directions. You just need to kind of remember what they mean. If you don't know, make sure you let me know. All right. So, with that said, let's go ahead. Let's grab our book. And let's turn the book page over to 472. Okay, here we go. On 472, okay, I'm going to leave that up there. We'll talk about that in just a second. All right, I want to do, so meaning that you, right now, you can go ahead and put your pencils down. All right, you don't have to do number 1 on your homework anyway, so you won't even have to copy it down. But I do want you to just watch how this is, okay? So, on page 472, I'm going to take a look at number 1, all right? Now, just where you know, when you're dealing with probability work, you need to always make sure you read the directions. Because the directions can be a very similar looking problem, but the directions may ask a number of different things. Now, the other thing is sometimes the directions have the actual description of the game in them. And you need to know the rules of the game before you play it and find the probability of it. Okay, so just always make sure that you read the directions. Okay, so here we go. Let's close read these directions. It says, the spinner shown at the right is spun once. Determine the probability of each outcome. Express each probability as a fraction and as a percent. Then describe the likelihood of the event. Write impossible, unlikely, equally likely, likely, or certain. Okay. Now you might say, okay, Mr. Wilkins, what does it mean by describe the likelihood? Well, remember earlier in our definitions, there was something that said the probability of something was 1 out of 6, right? Now, a 1 out of 6, of course, pretty much means that you have a 1 in 6 chance. Meaning that another way of looking at it is you could say, theoretically, if you rolled the number cube 6 times, you would win 1 out of the 6 times. Okay, that's not very good. All right, that's not very good. Okay, now on the other hand, what if you won 0 out of 6 times? If you have a 0 in 6 chance of winning, is it going to happen? Is it ever going to happen? More than likely not. If something's never going to happen, how would you describe that in real words? Yeah, that's impossible, right? So what they're doing is they're going to take, you're going to see, they're going to take fractions and percents, and because, in math, we use fractions and percents, but in real life, if you talk about the probability of something happening, you're going to use probably words to describe the situation, not numbers. Okay, if you say something's, has a good chance of happening, that's probably what you say. It has a good chance of happening. It's likely to happen. But you don't go, there is a 15 out of 17 chance that it will, unless your brain was a computer, right? So the bottom line is that that's what this is talking about when it comes into the description. So here's what I want you to do. Take your book, flip it over back one page, actually two, to page 470. This is what they're referring to. So bottom line is if it has as a decimal a 0 or as a percent, a 0% chance happening, like you guys just said, it's impossible. Now for something to be impossible, it has to be exactly 0. It can't be like a 1 in a million chance, because that's not impossible. I mean, it's very, I guess probably not going to happen, right? But it's not impossible. Same thing can be with way over on the other end of the spectrum. If it has a 100% chance of happening, it's going to happen. It's certainly going to happen. 99.9%, oh, it's looking good, but there's that little tiny bit of chance that it's not certain. Okay? So, now on the other hand, in the middle, right, it's a little more flexible. Something that has a 50% chance of happening, they say as likely to happen as not. Some people say, how many of you guys have heard someone go, you got a 50-50 shot? Okay, we've heard of that, right? That's what it's talking about. You have a 50-50 shot, means you have a 50-50 chance of it happening, which is that. Now, more than likely, if it's around 50%, like 51, 52, 49, 48, you could almost still define it as that. Okay? But I want to share these two with you. Anything between that's bigger than 0, and I would say less than about 48, 49%, you could consider unlikely. Now, there's a big wide range of unlikeliness of happening, right? 22% chance is less likely to happen than something that's a 40% chance. But realistically, compared to a 100% chance, they're both probably unlikely to happen. Same thing could be said about the likely to happen. Even something that's a 99.9% chance, you consider, I personally would say it's highly likely. You don't have to use the word highly, but I mean that's kind of what it is compared to something that's 70% chance of happening, which both of them are likely to happen because they're of course more than 50%, but they're not certain. Okay, so when we do these on page 472, that's kind of what they're talking about. All right, so here we go. Let me go ahead and do this problem. I just want you guys to watch. So we have this spinner right here, okay, and it says it's spun once, and it says what's the likelihood of this to happen? Well, number 1 shows it's asking what is the probability of spinning a 6. That's what that means. Okay, it's kind of its abbreviation. What's the probability of spinning a 6? So here's what we're going to do. Step 1 is you are going to write the number of possible outcomes. In this case, all you're doing is counting the sections. They're all equal size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible outcomes. That goes on the bottom. Step 2. Basically, this is how many chances do you have to win. This is what they call it in math. Favorable outcomes. The favorable outcome, everyone, is that right there. What's the probability of spinning a 6? Well, I take a look. 6 is only in one section. Now, I could reduce if I wanted to, but I can't in this case, right? So I have a 1 in 10 chance. Now, if you want to change it, you have two different things you could do, right? It does say, this is one of your answers. They did say put it as a percent. So you have 1 of 2, if you want to, right? Equivalent fraction over 100 times 10. A 10% chance. You can do it that way. Okay, obviously, if you didn't want to do it that way, you can grab a calculator and say, oh, and that looks like that battery's gone. Maybe not. I was hitting the wrong button. So, 1 divided by 10, right, gives you the decimal. Move the decimal over twice. All right, you still get your percent. So just a quick review on that. Okay, but you need a fraction, you need a percent, and then you need the likelihood, a description of the likelihood. So 10%, if I was to look on this page, is not impossible, but it's definitely not 50% either. So you would just describe it as unlikely. It's unlikely to happen. And that's how you do these problems. Okay? So not too challenging. Okay? So what I'm going to say is let's do this next one together. I started writing the steps on that last one, but we're really going to write the steps on this one. Go ahead, and on the same page, let's take a look at problem 16. All right, here we go. Problem 16. If we take a look here, we've got to make sure we read the directions. Let's close read this. It says a dartboard like the one shown is divided into 20 equal sections. Determine the probability of each outcome if a dart is equally likely to land anywhere on the dartboard. Okay, basically another way of saying each section is equal in size. Okay, and I guess you're randomly throwing it without aiming, I guess, is what they're trying to say as well. So it says express each probability as a fraction in a percent, and then describe the likelihood of the event. Okay, and that, of course, the rest of that is just like our last one. Okay, so number 16 says, what's the probability? And now all of a sudden we just don't have something extremely simple, not that it's much harder, but they have a description of a favorable outcome. Not so much the favorable outcome, but a kind of a description of it. And they said, what's the probability of you throwing the dart randomly at the dartboard and getting something greater than 16? So here we go. Step 1, total number of outcomes go on the bottom. And the total number of outcomes in this case are 20 sections, so that's our bottom, 20. That's the total possible outcomes. Step 2 is favorable outcomes go on top, meaning how many ways can you win? Well, that of course is the description here. Anything greater than 16. So on a dartboard that's labeled 1 to 20, what do we got? The sample space would be, is 16 a winner? No, but 17, 18, 19, and 20, right? But yeah, you're right. There are 4 of them. 4 sections that are favorable outcomes. Now comes step 3, and that is we need to simplify. Simplify the fraction. So I divide both top and bottom, numerator and denominator, the ratio, by 4, and I get a 1 in 5 chance. That's our first answer. Step 4, because they ask for a percent, let's convert it. Well, I can make it into 100. 5 times 20 is 100, so 1 times 20 is 20, which would be 20%. And step 5 is, you can look at page 470, but of course we just did a problem like this, right? Anything between impossible and basically 50% is considered unlikely to happen. All right, guys, questions on that one? Not too hard, right? Okay, go ahead, and I want you guys to try problem number 14. Number 14, go. Anyone still working on that problem? Okay, a few more seconds. Okay. 30 seconds. Turn to your neighbor and share. Go.
I got 1 over 2 for the fraction, 50% is equally likely.
Oh, I forgot to put the. I got 2 and 20%.
Oh, it's 50%. Because it's 1/2.
Okay, so problem number 14, same dartboard, right? So they're asking, what is the probability of, and again, this one's more of a description of a favorable outcome, an odd number. So, of course, same dartboard. Possible outcomes is a total of 20 different equal sections. Step 2. Favorable outcome. Well, odd between 1 and 20 is every other one. It's half of them. It's 10. If I reduce, of course, that's easy. Divide both by 10, I get 1/2. I now convert it to a percent, and hopefully that's mental math for you guys. That's 50%. And if I was to look, right, even at the directions up above, they kind of took some of the terms on page 470 and abbreviated them a little bit. They just tell you to describe it as equally likely. They're both equally likely to happen. Doing an odd or its complement. Winning to not winning. All right, questions, guys, on number 14 on that type of problem. All right, one more type of problem on here. So let's go ahead and let's take a look on page 472 at number 24. Okay, what we see on the same dartboard problem, but what we see on number 24 is now we see something that maybe is a description of something that's like a complement. So what's the probability of hitting something that is not a 4, a 5, okay, or a 6 on that dartboard? So obviously, the favorable outcome is everything else. So I go ahead, going through the same steps. All right, I just wanted to do one that's a complement with you guys. So bottom number is total outcomes is 20. 20 different sections on the dartboard. Favorable outcomes, well, if you wanted to, you could say, you can go through your head and go 1, 2, 3, okay, not 4, 5, 6, 7, 8, you could do that, right? Or, of course, out of the 20, there's only 3 of them. The complement, if there's 3 of these, how many are its complement? 17, right? Its complement has 17 favorable outcomes. All right, and what we see here is 17 out of 20. Can we reduce it? Now, 17 is prime. 1 and 17 can go into it, but 20 can't divide by 17. That is definitely, that's why I showed you this earlier, that is definitely one where we're going to want to grab a calculator. And, grab a calculator. 17 divided by 20 equals 0.85. Move that decimal over twice, and I get 85%. It's not a certain event. It's pretty good chances, though, right? This is likely to happen. All right. Questions about that one? All right. Here's the one I want you guys to try. 28. 28. Go. All right, how many of you are still working on it? We're okay? All right, 30 seconds. Turn to your neighbor and share. Go.
I got 1/2 or 1 over 2, 50% equally likely.
All right, here we go. Probability of randomly throwing the dot and hitting something that is not odd. All right. So, dartboard, same dartboard, meaning 20 equal sections, 20 possible outcomes. Favorable outcome, something that's not odd. How would you describe its complement, guys? How would you describe the complement of not odd? Even numbers. Thank you. Even numbers. Okay. Now, of course, now we can go to what you guys just said because that's obviously what your minds were thinking. How many even numbers? 10. Yeah, 10, right? Reduces to 1/2. And of course, we just had this, statistically, this kind of problem here. It's 50%, which is equally likely. All right, so very basic probability of simple events. Okay, any questions?
So if it's like 49%, can you still put equally likely? That's what you said.
You know, I did say that. So if you put that, I wouldn't, because realistically, if you describe it as equally likely, it really isn't, right? Because one's 49 and one's 51. So if you describe it like that, you know, I guess you would say that it's not quite equally likely. So I would be okay with unlikely, okay? But it's kind of hard to call it unlikely, right? But it's probably a little more correct than equally likely, okay? Like in real life, if I was to say something 49%, I'd be like, I pretty much have about a 50-50 chance, right? That's kind of how you would describe it. So if you put about equally likely, I'll be okay with that too. As long as you kind of know how the spectrum works. Okay. Other than that, any other questions? All right, guys. Probability of simple events.